functions. Today we learned how to do sum and difference of perfect cubes. So one of the things that keeps coming up in this class is that factoring in itself isn't all that difficult. Stuff that we've been doing. Yes, we're learning two new strategies, but the hard part of this unit is deciding how far we need to go. Are we going to factor on top of factoring? Can we factor further? So the questions that we want to always ask ourselves when we're looking at a factoring problem is, can I take out a GCF? So I always want to start with, and if you want to write these questions down, I would in my notes. 1, is there a GCF? If there is, take it out. That's where we should always start. Then when I get down to it, then I want to ask myself, are there 2 terms? Are there 3 terms? Or are there 4 terms? Now, if there are 2 terms, then I can check to see, 1, is this first term a perfect square? Is there a minus sign? And is the second term a perfect square? If that's the case, then I'm going to do a difference of squares. If they're perfect cubes, we want to check for that. So is there a perfect cube? Plus or minus perfect cube. If that's a yes, then we want to do a sum of cubes. If there are 3 terms, then we're going to do that box and diamond. If there are 4 terms, we're going to do factor by grouping. Now remember, when we factor by grouping, we learn 2 different strategies. There's also a box. You can put all 4 terms in the box. So it's like the box without the diamond. Okay? So then we put all 4 terms in there and we do it. So if you have any questions on that, please come in and ask. But otherwise, this is where we started. So this is what I had everyone put in their notes. So go ahead and hit pause and put this in your notes. So when we put these in our notes, sorry, another teacher came in really quick. Okay, so when we are looking at a sum of perfect cubes, notice that the first term is a perfect cube, the second term is a perfect cube. It doesn't matter if it's a plus or a minus sign. If they're both cubes, then we are going to be able to do either a sum or difference. So the first thing that I always say, so if we're looking at a cubed plus b cubed, then I want to find the cubed root of a cubed. Well, that's going to be equal to a. And the cubed root of b cubed, and that's going to be equal to b. So it's a lot like what we've done with the difference of squares, where we took the square root of each term. Then what I want to do is I'm going to set up my parentheses. So I have my first set. I know it's going to be a binomial. That's this part right here. Then I'm going to do my trinomial. Okay? And this is how I always do it. I say this. First, we're going to stay the same. The sign stays the same. Then it's different. And we end on a positive note. I'm going to square the first term. I'm going to square the last term. And then they both go in the middle. So then my first term is the first one that's right here. It's the cube root of this, which was a. Then my second term is the b. It's the second term right there, which is b. And then this is going to be my first term, and that goes in the middle, and then my second term. That goes on the last part. And then I just have to simplify my trinomial. So I'm going to end up with a plus b times a squared minus ab plus b squared. So you're going to do the same thing with a difference of squares. A difference of perfect cubes, a difference of cubes. So so go ahead and make sure this is your notes. Now we're going to do a couple of problems. So I've already gone through it where I did an a cubed plus b cubed. Now I want to do it with some numbers. So what I want to do is I want to look at 64, and I know that 64 is a perfect cube because 4 times 4 times 4, or 4 to the 3rd power, is 64. I also know that 125 is a perfect cube because 5 to the 3rd power is 125. So what I want to do, since I know that these are perfect cubes, then I want to find my a. So a is going to be equal to the cubed root of 64. And I know that x cubed is a perfect cube. So I want to find the cubed root of x cubed. And I'm going to do the same thing here. So my b is going to be the cubed root of 125. And I'm going to do the cubed root of y to the 6th. Now, I talked about how when we did a difference of squares, that if it was an even power, then it definitely was a perfect square. Well, if your power is a multiple of 3, So if this exponent is a multiple of 3, then it is a perfect cube. Because so just like when we took, like here, I'll do it over here. So when we took the square root of x to the 8th, that equaled x to the 4th, and that's because we took half of this power. We're going to do the same thing, but instead of taking half, if it's a cubed root, we're going to take 1/3 of it. So the cubed root, as I already said, of 64 is 4, and the cubed root of x cubed is x, so that's what my a is going to equal. And then my b is going to be 5, and the cubed root of y to the 6th, well, 1/3 of 6 is 2, so it's going to be y squared. And that kind of makes sense, right? Because if I do y squared times y squared times y squared, I get 1, 2, 3, 4, 5. I get y to the 6th. So my b is 5y squared. My a is 4x. So now I'm going to set up my parentheses. And just like I said, I'm going to start with my binomial, and then I have my trinomial. Now my sign stays the same. I have a plus, so that's the same. Then it's different. I always end on a positive note. I'm going to square the first term. I'm going to square the last term, and then they both go in the middle. So my first term is my a, which was 4x. So I'm going to write my 4x where it belongs. Then I'm going to write my b, which was right here, so 5y squared, and that. Notice that I write it 3 times. I write my first term 1, 2, 3 times. I write my second term 1, 2, 3 times. So then the only thing I have left to do is simplify this. So then I end up with 4x plus 5y squared. Now, 4x squared is really 4x times 4x. So 4x times 4x is 16x squared. So be careful that you got 16x squared. 4x times 5y squared is 20xy squared, and then 5y squared squared, so 5 squared is 25. Y to the second power is going to be y to the 4th power, because I'm going to get 5y squared times 5y squared, and when we multiply variables with exponents, we add them. So then that would be my final answer. So when I look at a difference of cubes, it behaves the exact same way, except my signs are a little bit different. So if I take the cube root of all this, notice that they're the same. So my a is going to be 4x for this one, and my b, so then my b is equal to 5y squared. And then I'm going to do the same thing. I'm going to set up my parentheses. So in my binomial, the sign stays the same. In my then it's different, so I have a plus, and I always end on a positive note. I'm going to square the first term, square the last term, and both go in the middle. Then I'm going to write my a term, my first one, which is 4x. So 4x goes, and then 4x goes right here. 4x goes here. I've written it 1, 2, 3 times. Now I got to write my b term. So 5y squared, 5y squared, and 5y squared. So now I just need to simplify this last part, which I can check my answer right here. So I'm going to end up with 4x minus 5y squared. And then I'm going to get 4x squared, which is 16x squared. 4x times 5y squared is 20xy squared. And then 5y squared is plus 25y to the 4th. And then I'm done. So the moral of the story is that is how you do it. If you have any questions, please let me know. We did do some extra problems. We did these ones. So go ahead and try these ones on your own. And I can check your answers when you come into class.